So this is going to be a brief tutorial on the use of R for running Monte Carlo simulations. So for those of you who don't yet know about this, write scripts to run our statistics or analyze data or build models or do many other very exciting things, which you can find out more from R or from other videos from this tutorial. But essentially, we're going to be diving into this exciting world of Monte Carlo simulation. We're going to use R as our interface, but we're here really to think about Monte Carlo. And Monte Carlo, you can think of it as a kind of model-based crystal ball. So it's going to help us. It helps many people in many different fields predict outcomes and understand risks. And it's used a lot in finance, statistics, risk analysis, and business, and all kinds of other applications. And it basically helps us to simulate the unpredictable nature of the system, to simulate change and to understand ripple effects. So imagine that you can peer into the future and see how different scenarios play out. It helps, if that's possible, if you're able to do that, it helps you to grasp the full picture of uncertainties and possibilities. So we're going to run Monte Carlo in R, and I'll invite you to follow along with the code. You'll find it in my GitHub repository. I'm at CW Whitney. I'll write that here so you can see at CW Whitney. You'll find that if you look that up in GitHub, you'll find a repository on running Monte Carlo in R. So essentially, let's do a super simple one. So I'm just going to do, first thing I need to know is how many simulations do I want to run? So I'll call it number of simulations, and let's say that's a pretty common number is 10,000, because we imagine running 10,000 possible futures. So I'm going to call this object number of simulations 10,000. So I'll have 10,000 simulations. And we'll use the example. Let's think of a simple example. Since I'm at the Horticulture Institute, we'll work on a horticulture example, and let's think about apple production. So let's say we have let's first we're thinking about apples. So let's say we're going to think about the costs and benefits. So let's just try to generate a general, sort of simple but general assumption about what a farmer might be facing in terms of cost and benefits for a hectare of apple production in a year, let's say. So I'm going to do apple income. I'm going to have to generate a range, right? This is going to have to, so I'll make a list with C to write this range, and I'll call it 30,000 and 60,000. So here I've got a number of model runs, and now I've got a range. I'm naming the apple income range between 30,000 and 60,000 in a hectare in a year. It might be high. Maybe you have some other ideas if you're into horticultural production, but let's just take this first model assumption, and then let's also do a range of costs. So let's do a range of costs of, and let's say another list with the C function, 15,000 and 30. So I'm thinking costs could be from 15 to 30,000 here, just as a general assumption. Now, what I want to do is assess that income, because I have the range. I know what it might cost in a year, but I want to be able to run this many times to see what we can expect in terms of possible futures. So I can say apple income could be, I can run the run if function, and I can say I'm going to run it. So the run if function has first of all the n, and our n is going to be number of simulations. Number of simulations. I'll put some space here to make it prettier. And we have to have a minimum value. So our minimum value will be the apple income range. Remember, our apple income range and we want to take the first value there because we have two values, remember, in the Apple income range. So we're going to take the first value, which again was 30,000. So that's our lower bound. And then our max will be the next Apple income range, right? Apple income range. The second value of our Apple income range, which was 60,000. So now I'll run these 10,000 simulations with the runIf function, 10,000 simulations of Apple income being from this minimum value of 30,000 to the maximum value of 60,000. So I'll run that. And now I can check what Apple income is. And we can see it's this giant list of values, 10,000 values of that, of possible numbers between those two ranges that we set up. Now, that's Apple income. So I've got my Apple income there. Now I want to do Apple costs. So I'm going to do Apple costs because I want to compare these. Let's see, I need a little arrow. And I'm going to do runIf again. And now my n number of runs is once again num simulations. I wonder if that shows up here. Yeah, number of simulations. My min is remember we wrote that before, Apple cost range. So that's probably going to show up here if I do this Apple cost range, and I want, once again, first character. And my max is going to be the Apple cost range and the second character, which if we look back above this giant pile of numbers from our 10,000 model results, I don't know if it goes that high, then we can find again that the Apple cost range went from 15,000 to 30,000. So those are the two values we're using here. We scroll back down through this huge list of 10,000 model results, and we find that we're using the Apple cost range too. So we have Apple costs, but I want to name that Apple cost and not Apple costs, APPLE cost, Apple costs. And now I can do summary. Let's not get a giant list, but let's do a summary of Apple costs. So that we don't have to look at 10,000 numbers. So there we can see that same list, 10,000 list, and we can do the same thing for Apple income. So we've got our Apple income here. So we can see that actually the maximum value is quite a bit higher for the income. The minimum values are higher for the income. So it looks overall like income is a little bit better than cost. So it looks like overall they're not really losing much money or not losing money. They may even be earning some money with their Apple production system. And we can calculate profits by doing Apple profits. And how would we calculate profits? By doing Apple income minus Apple cost. And now we can do another summary. Let's go up here, Apple profits. And we can see that overall there's mostly earnings from Apple production. We can look at that. So the summary may be a little bit hard, so we could try to make a histogram. Apple profits. We could do a histogram of profits and see. I hope that's possible for you guys to see. Let's see if I can change it. So we can do a histogram of those Apple profits to see that overall there's a positive earning here. So for the most part, there's some earnings going on. I can add some lines here to tell us the Apple profits. Yeah, let's run that. Yeah, so I can add some lines here to suggest the something about our confidence. So we've got this line in the middle, this new line in the middle. You can see where it meets on the x-axis. The x-axis, by the way, is our expected earnings. our expected profits. And this line right here in the middle that just appeared from the x-axis going up represents 50%. So 50% of the values of our simulation are below this line, 50% above. So we can expect half the time to be here and half the time to be here. And these other lines, these lines over here represent our 10 and 90% confidence. So we can expect one day or let's say 1 year out of 10 here to be below this much in earning, and 1 year out of 10 to be above this much in earnings. So that may help decision makers to think about how to manage their system in order to account for that possibility. So let's new share back to our R console. I added those lines with the AB line function when you're plotting in base R. So let's talk about, I want to talk about one thing here, which is that run if function. We use this run if function. You can find out more about run if by looking it up in the R handy files that come with our R interface. But essentially what run if does is it generates random numbers from a uniform distribution. So it's assuming the distribution is uniform, and it basically takes that minimum and that maximum value and runs that for us. So the simple way to write it would just be to say, with our number of simulations, which of course is 10,000, as we recall, we can just give it the minimum value and the maximum value, and just run that as our income. And then again, using the run if, we only need to supply minimum and maximum. So we run 10,000 model simulations of those minimum and maximum values that we named before. And then our results are, again, the income that we've just generated minus the costs with this run if function. And we see plot results, we'd see the same values again. There's our histogram of those results. Similar outcomes. The x-axis here again is the earnings expected, and the y-axis, we didn't talk about this before, but the y-axis is just the frequency. So of those 10,000 runs, some of them landed here in this range, but lots of them, and some in this range, but lots of them landed around here. So we can expect in lots of the cases this kind of an outcome given our model assumptions. New share, back to our R interface. So now, essentially, that's what we're doing. So let's do, why might this be useful? That's one thing. It might be useful for projecting some kind of outcomes of a general system outcomes in a simple sense. But let's add a little bit of complexity by suggesting that maybe there can be some income from changing our system from that just apple production. Maybe the farmer isn't interested to know what are my expected earnings or expected profits from a hectare in a year, but rather should I make some kind of system change? So we can take our assumptions about the way a system functions. Of course, it'll be much more complex than this, but this is just for an example. What we might do is the farmer might be interested, for example, in incorporating livestock like sheep into their orchards, maybe to deal with weed control, to provide manure for fertilization, and diversify income streams. Agroforestry options can offer all these things and more. So let's try and make a little bit of an assumption about sheep. So let's say that if we have sheep, then we'll have some sheep income. And then we're going to use that run if again. And we'll still use number of simulations. So sorry, I'll use the functions here. So n equals number of simulations, min. Let's come up with a min that's reasonable. Let's say that it's not too much, minimum 2,000, and let's say that the max, you just hit tab, you'll see the options is 5,000. can see that I make typos sometimes, so I like to try to use the default, make sure I'm using the correct default arguments. The max is 5,000. So now we're simulating some sheep income, and let's do the same for sheep costs. So these are what we expect in terms of additional costs by adding sheep, additional income to adding sheep in the orchard, and additional cost of adding sheep to the orchards. And I'm going to again make the n num simulations, which you'll recall is 10,000, and I'll make the min. Let's say it's 1,000. So we stand to expenses are 1,000, and the max expenses are 3,000, for example. So now we've got sheep incomes. So sheep could be, we could sell meat, wool. We could sell other things. Maybe it's a petting zoo. And we could have some costs. Of course, sheep need food. They need veterinarians. They need lots of different things. So they need fencing, right? So we can expect some costs there. But overall, we think the income will be a bit more than the costs. So we've increased the upper bound here for the income is higher than the upper bound for the costs. Likewise for the lower bound. And so now we can calculate sheep. Let's do sheep results. The addition of sheep. So that would be sheep income minus sheep costs. And we can do a summary of, let's do a summary sheep results. Now we can see that overall there's a possibility. So there's a negative value here. So it's possible that they lose some money if they integrate sheep, or just through the sheep integration. But that overall, it looks like they're doing okay. They're getting some money out of that. So let's also think about so we had up here our apple profits that we calculated, right? So we've got our apple profits, and these are actually sheep profits. We can do that one more time to make sure we're consistent. So let's call it sheep profits. Okay. Now we've got our apple profits, which we've calculated here, apple income minus apple costs. And we've got our sheep profits, which is our sheep income minus sheep costs. And now we can also come up with a total. So let's say we're comparing these. So let's put our total profits are apple profits plus sheep profits. And now we could also do a summary of that. Summary of spelled everything correctly. Then we see a distribution here, which is positive. So it seems like overall there's some earnings, but let's compare all of those together. And it's not easy to do in tabular form. So we'll try to do it with the histogram function again. So hist is just the base R function. You can look for some of those functionalities, but essentially it'll plot for us our results in a way that we could even compare, because it has an add equals true option. So I'm going to do the apple profits. So I'm going to do a histogram of the apple profits. You can't see that because I need to switch the screen share. Yeah, you're looking at the histogram of the apple profits. And now I want to overlay a histogram of the sheep profits. I'm just going to do the same thing, hist sheep profits. And now you can see that the sheep profits, we remember some of those were negative. Some of the results of that distribution were negative, but for the most part positive, but not by very much, just a little bit of positive. But we could compare them because we did our total results. So I could add an additional histogram here. Our total profits. In red or in orange here to show how they compare. So we've added, by adding sheep to our orchard, we've added just a little bit to the profits, and we've sort of shifted our distribution a little bit to the right, to the more positive. So the key points here are just that Monte Carlo is this kind of crystal ball. It allows us to build simulations of the future. We've worked on a very simple example of an comparing agroforestry options. Extremely simple. Of course, the model would be much more complex when we're dealing with this in the reality or in a realistic situation. We'd add a lot more variables to our model, and that structure, the structure of that process, we can talk about in other videos. But I just wanted you to see in simple terms how to apply this in R, and I think that that is enough for now. You can find out more from the rest of the video collection or visiting the website of the course that this tutorial's for. And I wish you good luck in your R coding and in your model building. Goodbye.